In this video, we're going to talk about functions and their corresponding graphs. The first thing I'd like to discuss is domain of a function. So just like we talked about in class, the domain of a function are all allowable values for x. Or, in other words, our input variable. So the first problem is asking us if the point, the ordered pair, 1, negative 1, comma 2, is on the graph of the function f of x equals 2x squared minus x minus 1. So if we were to graph this, would this ordered pair be on that graph? Would it be a part of that graph? To do that, we are going to substitute. The first part is, I think, pretty straightforward. We know that the x variable is going to be negative 1. Typically, we would write this as y, but remember y is the output variable for an equation. We have a function, so in this case we have to have the output variable is going to actually be equal to f of x. So we will substitute for f of x positive 2 rather. So this will be 2 is equal to 2 times negative 1 quantity squared minus negative 1 minus 1. And what we're doing here is doing our order of operations to verify that this does in fact make the function true. So we have on the left side 2 throughout the entire process. On the right side we will do order of operations. This will become 2 plus 1 minus 1, which does in fact have 2 equals 2. So the answer is yes. The point or ordered pair negative 1 comma 2 is on the graph of this particular function. So 1b and 1c, we're going to continue using the same function that we just dealt with. And what I'm asking here is if the input value is negative 2, then what would the output value or f of x be? So again, it's maybe worthwhile to write down our function. Our function was f of x is equal to 2x squared minus x minus 1. So from here, we go ahead and substitute negative 2 into our function for x. Now, function notation, we will write this as f of negative 2 is equal to 2 times negative 2 quantity squared minus negative 2 minus 1. All right, order of operations. Remember, this is function notation, so we're actually, the f does not represent the variable. It just represents the function notation. So on the right side, we'll do order of operations. Negative 2 squared will be 4. So we have 2 times 4 plus 2 minus 1. We have f of negative 2 is equal to 8 plus 2 minus 1. And finally, 8 plus 2 is 10. 10 minus 1 is 9. Okay, so the output for the input variable negative 2 or the input value of negative 2 is 9. So you could even write this in an ordered pair. It would be negative 2 comma 9. With 1c, we're given the output value, which is negative 1, and what we're asked to find is the input value. So first thing we should do is substitute the output value in. So it's going to be negative 1 is equal to 2x squared minus x minus 1. Now, to do this, we actually have a quadratic equation, and we're going to solve this using all the methods we know. I'm going to choose to, well, first of all, no matter what, we have to get this equal to 0. So I'm going to add 1 to both sides. So we have 0 is equal to 2x squared minus x, because the negative 1's all canceled out. And now what we have is quadratic we can solve. You can use the quadratic formula if you'd like to. I would argue that the easiest method would be to factor. So we have 0 is equal to, and you notice here that we can factor out a GCF, which is x. That would leave 2x minus 1. Sorry, sloppy parentheses. And so from here, we set both the factors equal to 0 and solve. So x is equal to 0, and 2x minus 1 is equal to 0. Add 1, 2x is equal to 1, And so then x is equal to 1/2. So we actually have two inputs that will correspond with the output -1. And what we have is 0, -1. And we also have 1/2, -1. Remember, this is still a function because of the fact that for any input value, we have one and only one corresponding output value. So this does still continue to satisfy our definition of a function. With 1D, we are going to list the x and y intercepts. So again, we have our function. I think it's worthwhile to write this down one more time. We're continuing to use the same function we discussed earlier, which is f of x is equal to 2x squared minus x minus 1. And we want to find the x and y intercepts. Just like we did with x and y intercepts of equations, no different. Let's start with the y intercepts. So y intercept, if you recall, means that I'm going to substitute 0 in for every variable x. So in other words, this is f of 0 is equal to 2 times 0 squared minus 0 minus 1, which equals -1. So your y-intercept is really just 0, -1. This one's the slightly easier part, meaning the y-intercept is slightly easier to find. The x-intercept will require just a little more work. In this case, we're going to substitute 0 for, and typically we would substitute for our y. But remember, the output, which is typically our y, is represented as f of x because this is a function. So we will substitute 0 for f of x, which means we have 0 equals 2x squared minus x minus 1. Again, we have a quadratic here, so what we have to do is solve this quadratic either by using the quadratic formula, completing the squares, or factoring. I'm going to try to factor this, so it'll be 0 is equal to, and I know we have 2x and x, and I know we have 1 and 1, and so what I'm going to have here is a negative and a positive. All right, so we have the factors of 2x plus 1 and x minus 1. Set those equal to 0 and solve, so we have 2x plus 1 is equal to 0, which means 2x is equal to -1, which means x is equal to -1/2. Likewise, we have x minus 1 is equal to 0, which means x is equal to +1. So again, we have two x-intercepts in this case, the first one being -1/2 rather, 0, and the second one being 1, 0. Lastly, what I'd like to do with this problem is find the domain. So remember, domain is all allowable inputs, and sometimes it's maybe too all-consuming to think about what you can put into the variable x, and instead think about what you're not allowed to. So remember, just one more time, this will be the last time for this function. Our function was f of x is equal to 2x squared minus x minus 1. And think, is there anything we cannot substitute for the variable x? Which means that, is there anything that would produce an undefined or an error of some sort for our output f of x? And I can't think of anything. This is good for 0. It's good for all positives, all negatives, fractions, decimals, basically any number you can think of, you can substitute in here, do your order of operations, and get an output for f of x. So what that tells me is that the domain is all real numbers, and this in interval notation is -infinity to infinity. Continuing with the same idea of domain, I have a new function now, and I'm asking what is the domain of this new function. Again, just as I said, all allowable inputs. So what could we not use? Well, you notice here right away we have a denominator, and anytime we have a denominator, it means that we cannot have 0 in our denominator because that's undefined. So we know x minus 2 cannot equal 0, so we have to think what value of x will produce a 0. So what we do is set that equal to 0, solve, and you get x is equal to +2. So in other words, if you take 2 minus 2, you get a 0 in your denominator, which makes this undefined. All right, it's the only restriction. It's the only value of x that presents a restriction. So I'm going to write this in two ways. The first being interval notation again. So we start with -infinity, which would be the lowest possible value, and then we go up to our first restriction, which happens to be 2. Well, we can't equal 2, so therefore we put a parenthesis around there. And we can then go from 2 to positive infinity. So that's your domain. Another way to represent your domain would be to write this in set builder notation. So x such that x cannot equal positive 2. All right. With 2b, we're going to use the same function and find the x and y intercepts. So the function, if you recall, is f of x is equal to 2x over x minus 2. All right, just like we did before, to find the y-intercept, you must substitute values, or you must substitute 0 for x and solve. So it'll be f of 0 is equal to 2 times 0 over 0 minus 2. This will produce 0 in your numerator and negative 2 in your denominator, which equals 0. So your y-intercept happens to be 0, 0. Okay, the origin. Let's find the x-intercept and see if there's any x-intercept that happens to be different than the y-intercept. Okay, to find the x-intercept, again, you're going to substitute 0 for f of x. So in this case, you'll have 0 is equal to 2x over x minus 2. Now, to do this, what you'll end up doing is multiplying both sides by x minus 2. What this does is cancels out the x minus 2 on the left side, or the right side. Now on the right side, you have 0 times x minus 2, which simply is 0. And then divide, and you get x is equal to 0. So there is only one intercept, and it happens to be the origin.
I love algebra.